So I really enjoy trig identities. I know that's weird, but hey, some people do the crossword puzzle. Some people do Sudoku, which seems like a total waste of time to me. So trig identities can be fun once you grasp the basic tricks. Then they're interesting puzzles to solve. I tell all my students this. If somebody could figure out a way to market trig identities so that they didn't sound like math, call them Pokemon identities or who knows what, you'd make $1 million. So challenge is on out there. Anyway, trig identities, you have a few basic tricks that you're going to be using. And one of them is use basic identities. By that, I mean if you see tangent, you should automatically think, aha, that's sine over cosine. And likewise, if you see 1 over secant, you should change that to cosine again. Did I forget to put the, yes, I did. And finally, if you see anything involving the squared functions, that's a good candidate for replacing with a Pythagorean identity. That would be 1 minus cosine squared. So using the basic trig identities is one thing that you will do. And the other basic thing that you'll do, there's really only two basic steps, although there's endless finesses of that. But the other basic step is do any obvious math. What do I mean by that? Well, if you see anything with a common denominator like sine x over cosine x plus tan x over sine x, those are fractions. Give them an LCD and add them up. If you see something where something is being distributed, you got a plus b inside and c there, go ahead and use that distributive property. If you see difference of squares, one thing squared minus another thing squared, try factoring it. So basically dig into your algebra toolkit and come up with just any obvious math. And usually a combination of these two things will take you a long way. So let's just look at a few. Let's look at a few basic ones. We're not going to kill ourselves. I'll record some other videos with some really tricky trig identities, but let's just look at some simple basic ones. So let's say we have sine x times tangent x times cosine x. And you're told to simplify that as much as possible. So you would first start by replacing tangent with sine over cosine, just like I said there. Sine x times sine x over cosine x times cosine x. And then you can cross-cancel that. And what you have left is sine squared x. In fact, if your job was to prove that this was equal to 1 minus cosine squared x, you would be almost there, because you would then use the Pythagorean identity, sine squared plus cosine squared equals 1. And you would say, therefore, sine squared, we can replace that with 1 minus cosine squared x. And voila, you've done what you were told. Let's look at one that might involve some of what I call the obvious math. So I will clear this screen. And let's say that we were told to try 1 over sine x plus 1 over cosine x, and we had to show that that was equal to cosine x minus sine x all over sine x cosine x. So here, although we could start by replacing 1 over sine and 1 over cosine with cosecant plus secant x, we would say, now we're really stuck. We're even further away from there than ever. So we'd suspect that that's probably not the way to go. And you know, sometimes that's going to happen. You're going to try something and it's just not going to work. But you have to try. I've seen students sit there and look at a problem. I've done this, you know, when I was first starting with trig identities. Sit there and look at it until you're like, I don't know what to do. You just have, if you see any way to start, even if you can't see how it's going to take you all the way, go ahead and give it a shot. Worst that happens is, as I just did there, you erase what you did and try again. So here the trick is, give them an LCD and add them up, because that's fraction addition there. So, sorry, not sine. I'm going to multiply 1 over sine by cosine over cosine. And the other one, 1 over cosine, I will multiply that by sine over sine. And so I have cosine x over cosine x sine x, and I have sine x over cosine x sine x. And now, carrying out the fraction addition, I have cosine x plus sine x all over cosine x sine x, which I can, of course, write as sine x cosine x. And looky, looky, looky. Ha ha! I have arrived where I wanted to be. I'm happy. Okay, we'll do another video with some more tricky trig ones first. But for now, remember, look for any basic trig identities, look for any obvious math, and often those two things are all you need. Good luck.